Hi, this is Mrs. Basin, and in this screencast we're going to talk about limiting and excess reactants. So in a reaction, the limiting reactant is the one that runs out first. So when you have your reactants, whether there's 2 or 3 reactants, one of them is going to run out before the others. What happens when that runs out is it limits the amount of products that can form. So the limiting reactant limits how much product you can make. When that limiting reactant runs out, the reaction stops. So we use the limiting reactant to figure out how much product we can actually make. So when we're calculating how much product could be produced, we always start with the amount of the limiting reactant. The excess reactant is the reactant that's left over, or the one that's not completely used up. So here's a visual representation of the reaction that produces ammonia. And we're going to look at the chemical formula, or the chemical reaction for this in a minute. So if you notice, we have H2 and we have N2. So that reacts to make NH3. So here's our reactants. There's our H2, there's our N2, and those together, it shows us on the other side, make our NH3, our ammonia compound. So we can very easily see with this visual representation that all of the H2s, all of these, get used up, because over on this side there's no more pairs of hydrogen atoms. What we do notice though is there is nitrogen left over. So in this particular reaction, hydrogen is our limiting and nitrogen is our excess, because hydrogen is completely used up, it's completely turned into product, but we still have nitrogen left over, so that would be our excess reactant. So let's look at how to apply this when we have a chemical equation. So in this particular reaction, this is our chemical equation for the reaction that we were just looking at. So our reaction is nitrogen gas plus 3 hydrogen gas gives us 2 moles of NH3, which we also call ammonia. So if we start out with 25.0 grams of nitrogen and 5 grams of hydrogen, we want to know how much how much ammonia or nitrogen trihydride we can make. So before we can figure out how much we can make, we have to figure out which one of these is going to run out first. Now you can't just base that on the original amounts. You have to go through and do the stoichiometry because of the relationships in the reaction. So what we're going to do is we're going to start 2 equations. So since I have 2 reactants, I'm going to set up 2 equations. One of them, I'm going to start with 25 grams of N2, and then the other one, I'm going to start with 5 grams of H2. And my goal here is to find out how much of each of these, how much NH3 could each of those make. So for my first one, I'm going to go from N2 to NH3. So from my first reactant to my product. So since I want to go all the way to grams, I'm going to go grams to moles to moles to grams. So I'm going to go all the way across my stoichiometry that we've talked about. The first step is to go from grams of nitrogen to moles of nitrogen. So 1 mole of N2 is 28.02 grams. Okay, now just something to note here, anytime you have a molar mass, the molar mass comes from the formula here, so since I have N2, I have to take N times 2, which gives me the 28.02. The other thing to notice is anytime you have a molar mass, it's always equal to 1 mole. Okay, so now I'm in moles of N2, so now I can go to moles of NH3. So now I can switch to my other substance. So to do that, I'm going to use the mole ratio from the chemical equation. So I have 1 mole of N2 for every 2 moles of NH3. So I'm going to put my 1 mole of N2 on the bottom, because that's what I want to cancel out, moles of N2, and then my 2 moles of NH3 on the top. Then my last step is going to be to change moles of NH3 to grams of NH3. And then again, I'm going to use a molar mass conversion for this. So 1 mole of NH3 is equal to the molar mass of NH3, which if I add all of that up, 17.04 grams. And then finally, I can do my calculation. So I multiply going across, divide top to bottom. So if I start with 25 grams of N2, I can make 30.4 grams of NH3. Okay, so now I'm going to go to my other reactant, my 5 grams of hydrogen. So now I'm going to see how much NH3 could I make if I started with that. So same deal here. I'm going to go grams to moles to moles to grams. Only difference is I'm starting with hydrogen. So first step again is to convert it to moles. So 1 mole of H2 is 2.02 grams of H2. Next step, I convert to moles of product. So this time again I'm going from H2 to NH3, my other reactant, to the same product. So mole ratio here, there are 3 moles of H2 for every 2 moles of NH3. And again, those numbers came from my balanced equation, or my ratio from my balanced equation, 2 to 3. Last step, just like before, is to go back to grams of NH3 using a molar mass. So same molar mass as before, because I'm going to the same product. And if I start with H2, I can make 28.1 grams of NH3. So once you have these values, you're going to look, and only one of those can be the correct value. So the one that's correct is the one that makes less. So the one that makes less tells you that whatever you started with is going to run out. So since the second one made less, that tells me that hydrogen, whatever I started with, is my limiting reactant. So what this tells me is H2 is limiting, and the reason it's limiting is because it made less product. Okay, so that means this one is not correct. So what I just figured out here is I first figured out the limiting reactant. So the limiting reactant is H2. And then the other thing we figured out in the process of doing that was the mass of ammonia produced. So we know it's going to be the smaller of those amounts. So the amount, or the mass of ammonia produced would be this amount here, 28.1 grams. Okay, I'm going to switch to the next slide then, and we're going to do the last part of this, where we figure out what mass of excess reactant remains. Okay, so now what I'm going to look at is, this is the same problem again, there's my same reaction. Now I want to know what mass of excess, or the other reactant, remains. Okay, so from the previous slide, we know that H2 was our limiting, so that means N2 was our excess. So if we want to know how much of the excess is left, now we're going to go from limiting to excess to find out how much was used. So now that I know what my limiting reactant is, any other problem I do associated with this reaction, I'm going to start with limiting. So my limiting reactant was my 5 grams of H2. So that was how much I started with. This time, I already know how much product I can make, so this time I'm going to go to N2 to find out how much of that I would use up during this reaction. So again, the first step is to go to moles. So moles of H2, 2.02 grams of H2. Next step is to do mole ratio between H and N. So it's 3 to 1. So 3 moles H2 for every 1 mole of N2. And then my last step is to go back to grams of N2. So 1 mole N2, 28.02 grams of N2. So from all of this, once I do my calculation, I get 23.1 grams of N2 used. So that's what this is telling me. This is telling me that when I start with my 5 grams of hydrogen, I'm going to react 23.1 grams of N2. So what the question is asking, though, is how much of the excess reactant remains. So how much is left? So what I have to do is go back and see how much of that I actually started with. So I had 25 grams available, and I used 21. So if I want to know how much is left over, I'm going to have to subtract. So 25 was available. So 25.0 grams of N2 was available. I'm going to subtract my 23.1 grams of N2 used, which I just calculated down here. So that would tell me that I have 1.9 grams of N2 left. Okay. Now if it asks me how much H2 was left, The answer to how much limiting is left is always going to be 0, because by definition, the limiting reactant is the one that runs out. So at the end of a reaction, there is always going to be 0 grams of limiting reactant remaining. To find the excess of any other reactant, say if we had another one, we would go through the same process again, starting with our limiting, going to our excess, and then subtracting from the original amount that we had.